Hi guys, I'm Pat Kelly. Okay, oh look, somebody left an integral for us. Cool, let's go ahead and evaluate that, okay? All right, well, here's what's really going on is with this section, what we've been learning is how to utilize these three different formulas, okay? So just to start, I'll explain. I have these three integrals laid out for us because the way that I approach most of the problems in this section is I'm trying to get the given integral to match one of these three formulas, okay? That's always my start with these problems is how can I take what's given here to match one of these three candidates. All right, so right off the bat, you might notice this middle choice is probably the best simply because of the absence of the radical. My given integral does not have any kind of square root in the denominator. And for each the first and the third, I need a square root. So I like this guy, but, and this is a pretty big but, there are only two terms in this denominator. You have a single entity of a being squared and a single entity of u being squared. But in our given integral, we have a trinomial. Okay, so this does not fit yet. Now, if you look back at the directions, they actually gave you a really big hint. The directions say to evaluate the definite integral by completing the square. I kind of left that in the background for a minute because what I'll suggest to you is you want to get to the point where you see this integral on your own and say, I think I can get this trinomial to be an a squared plus u squared if I complete the square without someone telling you that, okay? Keep those training wheels on for now. When they tell you to use completing the square, go ahead and do that. But start to think to yourself, I'm going to be the one that has to decide to come up with completing the square. That's a bit of a challenge. Okay, well, with those training wheels, I know that I'm supposed to take this trinomial, I'll just go off to the side a little bit, and I'm supposed to complete the square. So x squared minus 2x plus 2. I will choose to rewrite that. This one is not too bad because what I'm going to do is break the 2 up into plus 1, right? And I do that because these first three terms now are a perfect square trinomial, which means that they factor into x minus 1 parentheses squared. I still have that second plus 1. So this, which came from our denominator, equals x minus 1 squared plus 1. In other words, a single entity squared plus a single entity squared. In other words, that middle guy. So we're in good shape now. Okay, so let me get back to the actual problem and do a rewrite of this. This equals the integral still from 0 to 2 dx. But that denominator I can replace with my complete the square work. X minus 1 parentheses squared plus 1. And now this is really the new material, is how exactly do I get this integral to match one of my candidates? And we've already decided we're going to go with that middle guy. So the a is 1. That's good. All that's just a little bit different is my u here is actually an x minus 1 here. So we do a u substitution. You've probably been doing u substitution for years now. At least that's the way it'll feel, right? U substitution is just so useful. And this is a good u substitution because du equals dx. So down one more step, this equals the integral dx is the same as du. This is now u squared plus 1. Perfect match for this formula that we learned this lesson. And before I continue though, I don't want to forget that this was a definite integral. So my limits of integration were x's. I just need to convert them into u's using that equation. So when x is 0, u is minus 1. When x is 2, u is 1. Okay, now the formulas are really all about getting an immediate answer. Once you match this formula, you know that that's your answer. So I know that my answer here is 1 over a, but a was 1, arctan of u, and for us we're going, arctan of u over a, but again a was 1 for us, and we're going from a -1 to a 1. Okay, so we just need to evaluate this arctan of u from 1 to -1. Maybe I'll slide over to do that. Arctan of 1, subtract arctan minus 1. And now it's just evaluating those inverse trig functions. Arctan of 1, where is the tangent equal to 1? Pi over 4. Subtract arctan of minus 1, where within the domain is the tangent equal to a -1? That's actually a negative pi over 4. As always, watch your minus signs. We have a minus, so plus pi over 4 plus pi over 4. This equals pi over 2. And that's a great answer. Okay? All right, hopefully that helps you with some of these other problems. But remember, my advice here is, yeah, they tell you to use completing the square, but start to think ahead that you want to be the one that decides, yes, completing the square will serve me here. Okay? All right. Good luck.